What up? Time to go over the HL paper 1. And then again, for the sake of time, I'm not going to go over any of the questions that showed up in the SL paper. You will unfortunately just have to watch the SL video. I will point out if there are subtle differences, maybe like part D has been added on where it did not exist in the SL version or whatever. So for example, question number 2 in the SL is actually question number 1 in the HL, except they don't ask you part A. They literally just give you this and ask you to find the integral. So you're kind of just expected to do this on your own for the first one. And then the next couple of questions are all purely SL. And then our first actual HL question is question number 6. Which is a binomial expansion. So consider this binomial expansion for n to the power n, and then n is a positive integer. Okay, so determine all possible values of n for which the expansion has a non-zero constant term. So this is actually not the HL extension of the binomial theorem, because we are only considering powers that are, didn't realize I was off camera. We're only considering exponents of n that are positive integers. So this is basically just an SL binomial expansion. Constant term means that we have no power of x. And then what we can do is we can just do our normal binomial theorem expansion. So what would this be? N C R times 8x cubed to the power of n minus r times negative 1 over 2x to the power of r. Okay, so here is our general term, and then we need to find out what possible values of n will make this have a constant term, non-zero constant term. So what we can do is we can just look at the powers of x. So this one here and this one right here, and we can find out when we will have x to the power 0 constant term. So if I multiply this exponent of 3 in with this other exponent, I get that. And then from the second one, it's a reciprocal, so that's minus r. And then just continuing your exponent rules. The minus 3r minus r is going to be minus 4r, and then we can equate our exponents. And then if we were to solve for n, you get 4 over 3r. And unfortunately, this doesn't really tell us what n is, because we don't know what r is. But there are possible values of n. Oh, okay, hold on. Let me rewrite this. So because n is related to r, and it's 4/3 of r, and because this is the SL binomial theorem, and because and what I mean by that is n is a positive integer, we also know that if n is a positive integer, then r also has to be a positive integer. Okay, so that means, let me just rearrange this actually. So r is 3 over 4n. So the only way for r to be a positive integer is if n is a multiple of 4. So since r is a positive integer, then n needs to be some multiple of 4. Yeah. And then those are all the possible n's that would work, because then that means that r would be a multiple of 3, and then that satisfies this equation, which means that that satisfies this general term having a constant term. So yeah, n has to be a multiple of 4. Okay, next up. Continuous random variable x has a probability density function. It looks like that. That function right here. And then we need to find the value of k. So one thing is, well, it's a probability. So if we integrate it from 0 to 1, this should give me the total area under the curve, which is 1, because it's talking about probability. Okay, so all we need to do is take the integral. I'll take k out of the integral. We have to basically evaluate this integral. And this is going to take the formula booklet. And I believe this is an HL integral. I think that's something to do with yeah, your HL level standard integrals. We're going to use this one right here. So let me just copy that. Copy. Okay, so from this standard integral, we can see that a is going to be 2, and then the formula's x is going to be, in our expression, square root 3x. I'll just put quotation marks. This x is for the formula x, and then this is the question's x. Okay, so then what do we got? We got k is equal to the arc sine of root 3x over 2, evaluated at 0 to 1. So this is k. We got arc sine of root 3 over 2 minus the arc sine of 0. Okay, and then just keep in mind, arc sine is defined for, I think it's negative pi over 2 to pi over 2 or something. Okay. And then, so if that's the case, we can evaluate each of these. The arcsine of 3 pi over 2 is pi over 3. The arcsine of 0 is 0. And so we got k times pi over 3 needs to be equal to the total probability 1. So k is 3 over pi. Yeah, sure, that sounds about right. And then next up, find the expected value. So the expected value is this integral. Here, let me just show you the formula. There's a formula for it. Where's statistics? All we're going to do is we are just going to integrate the function, but multiplied with an x. So now we are multiplying with an x, and from here it is no longer an HL integral. Oh, and I guess, whatever, I'll just leave it as k. We can just use a u substitution. So du is negative 6x dx. In other words, 1 over negative 6 du is equal to x dx. And time to do a little substitution. We can pull out k, and then we can pull out the negative 1 over 6 from my u substitution. And what I'm left with is 1 over the square root of u du. Okay. And then this is from 0 to 1, right? Okay. So k is 3 over pi. We're going to multiply this by negative 1 over 6. And then the integral of the reciprocal of square root u is 2 u to the power of 1/2. And then we're going to evaluate this from 1 to 0. I think. Okay, so what do we got? So these will divide and get 2. So I have negative 1 over 2 pi. And then I'll have 2 minus 0 essentially. So this 2 cancels out with that 2. So my expected value is negative 1 over pi. It's kind of weird that you have a negative expected value. But whatever. Who am I to judge? Oh yeah, and then in case you couldn't tell, I know I said this in the Sl paper, but obviously this is literally the day of the exam after my class has written it, and then I get my own copy. So I don't have a mark scheme. I'm doing this blind, more or less. I read through them all, but aside from that, yeah, I'm in the same boat as you guys, sort of. Obviously with better math skills, but you know, it is what it is. Okay, integers, a, b. When you square them both and add them together, it will be divisible by 4. Prove by contradiction that A and B cannot both be odd. Okay, so we're going to assume that they are odd. So A and B are odd. So what that means is that you can write A as 2 times a multiple of 2 plus or minus 1, doesn't really matter. And then likewise, B is a multiple of 2. We should use a different integer though, plus or minus 1. And then K and M are integers. Okay. And then what we're going to do is we are just going to square these, right? Yeah, we're going to square them. So you'll get 4k squared plus 4k plus 1 plus 4k, not k, m plus 4m plus 1. Okay, so then if we were to collect the ones together, what you're going to get is 4k squared plus 4k plus 4m squared plus 4m plus 2. Okay. And since k and m are integers, well, here, let's just factor out the 4 from the first 4 terms. But essentially, because we can't factor out a 4 from a 2, then a squared plus b squared is not divisible by 4. As you can see, it has a remainder of 2 if you were to divide it by 4. So i.e. a squared plus b squared is not divisible. I think that's the sign, by 4. If you wanted this to be divisible by 4, then every single term should have a common factor of 4 in it, but it does not. Okay, next one. So we have two complex numbers, z1, which is 1 plus bi, z2, which is 1 minus b squared minus 2bi, and then b is a real number and it's also not 0. Find an expression for z1 times z2 in terms of b. Okay, easy enough to do. So we have 1 plus bi times 1 minus b squared minus 2bi. And then you can expand this however you want to. I'm just going to do this the long way. So 1 times that is 1 plus b squared. And then the bi times the negative 2bi is going to become positive 2b squared. So these are my real parts of the product, right? Negative, and then the two i's make another negative, which makes it positive. Yeah. Okay, and then let's do the imaginary part. So that's 1 times negative 2bi. So we have negative 2bi. And then we got this one right here. So bi times this. So plus b times 1 minus b squared I. And then, I don't know how far they want you to take it. Generally, we do like to only have one term of I, so I'm going to factor this out. And then also, generally, we like positives in the front. So we're just going to rearrange these two coefficients of I. And then this is a plus. And then this all is going to be multiplied by I. Okay. And then I guess you could simplify it. I need to find the argument, so I might as well simplify it because it'll probably make things easier later. So the real part is going to be 1 plus b squared, because we have a minus b squared and a plus 2b squared. And then the whatever part in the imaginary part. Sorry guys, it's like 1 in the morning. And so I'm sleepy. But I guess that makes it, you know, test situation accurate because you guys would have stayed up. Okay, what is this? This is going to be b what? Hold on. Multiply the b in so you have b minus 2b. Okay. So this is negative 1 or negative b minus b squared. So it's more or less the opposite of the real part. Sure, whatever. Actually, no, it's not. 'Cause never mind. Forget what I'm saying. Okay, what the hell are you supposed to do with this? Hence, given that the argument is pi over 4, find the value of b. Oh, sure, okay. Okay, so if we were to graph this on some sort of Argand diagram, it's saying that the angle here is pi over 4. And so your imaginary part and your real part are right here. And then you can do this without trig, or you can do it with trigonometry. But if your angle is pi over 4, that's 45 degrees, which means that this is actually an isosceles triangle, and the two sides are going to be the same. So we know that the imaginary part is equal to the real part. So we can just equate the two. So 1 plus b squared is equal to negative b minus b squared. So collecting everything to one side, we get 2b squared plus b plus 1 is equal to 0. And I don't think this is factorable. So, what am I supposed to do? Find the value of b. Shouldn't there be two values if I'm using quadratic formula? Did I mess up something? Maybe I did. Let me just check all of this for now. B minus 2b is negative b. Okay. Yeah, I don't know. There should be two values of e. Oh well, we'll keep going, and then something went wrong somewhere, I guess. B is equal to -1 plus or minus 1 squared. Yeah, something went wrong. Because this has no solutions for B. Did I mess up the multiplication somewhere? Okay, 1 times this stuff is, well, this stuff again. Bi times -2 bi, so you get a b squared, you get a 2, there's a negative, and then the two i's make another negative, which makes it positive. Okay. 1 times -2bi is going to be -2b with the I, and then this one times that one is going to be this. Okay. -b plus 2b squared is positive b squared, and then you have a b minus 2b, so that's minus 1b. Oh, this should be cubed. Cubed. So this is b cubed. So this leads us to a whole nother type of issue. So we got b cubed plus b squared plus b plus 1 equals 0. Okay, and then there's lots of ways to do this, but the easiest one is by inspection. B has to be -1, because then you'll have obviously -1 cubed, which is -1. You'll have -1 squared, which is +1, and then you'll have E, which is -1 plus 1, so then they'll cancel out. So there you go. There's B. Okay. And then now we move on to section B. So the first question is actually mostly an SL question. Let me go find it. It's the one about log. This one, here. So the natural log, if it's geometric, if it's arithmetic, and then the SL question, sorry, the HL question changes the last question, B, I. So what it says instead is now, oh great, I need to change back to the HL page. And then it says this. Instead of finding n when the sum of the first n terms is whatever it was here, -3 natural log x, they write it like this. So it's a little bit different. Obviously it's the same question because 1 over x to the power 3 is x to the power -3, and then you can take the -3 and then write it as a coefficient using log rules. But like I said, that is something that an HL person is supposed to do on their own, compared to where this kind of already guided you and did that part for you. But anyways, go watch the video to finish that off. And then we have the plane question. So consider these three planes, show that the three planes do not intersect. So do they this one confused me when I read it earlier in my, I give myself the 5-minute read through, because do they mean that all three planes do not intersect like with each other? Or do none of them intersect at all? Because if they don't intersect at all, then they all have to be parallel. But does this count? I'm assuming when they say do not intersect, then that means that all three planes don't intersect all together at once. So that's pretty easy to show. Basically, you need to make sure that your coordinate x, y, z, there is no coordinate that satisfies all three of these at once. So you're essentially just solving a system. So from there, let's do this using matrices. So I'm going to use equation for plane 2 first, so that I have a 1 in my upper corner. And then I guess the other two don't really matter. Okay, so we have 1, -2, 3, and 5. That's the second plane. And then the first plane is 2, -1, 1, 4. Third plane is -3, sorry, -9, 3, -2, 32. Okay, so we're just gonna, I guess, reduce this, and then eventually you'll see it's an inconsistent system, which means that the planes do not all intersect. Okay, so I'm going to take the second row, and then I'm going to subtract 2 of the first row, and at the same time I'm going to take the third row and add 9 of the first row. So you got 1, -2, 3, 5. You'll have 0 and 0, which is, you know, the point of reduction. Okay, and then now we do this mental math. So -1. Okay, let's go backwards. -2 times -2 is +4, and then I'm going to add that to -1, which I think is +3. -2 times 3 is -6, plus 1 is -5. -2 times 5 is 10, plus 4 is -6. -10 plus 4 is -6. Okay, -2 times 9 is -18. -18 plus 3 is -15. 9 times 3 is 27. So this is 25. And then lastly, we have 5 times 9 is 45. 45 plus 32 is 77. Okay, and then hopefully you guys can already see that this is going to become an inconsistent system, just because these guys are basically multiples of each other, but this one isn't. But in case you can't see that, we are going to continue to reduce. So I'm going to take row 3, and I'm going to add 5 times row 2, so that I'm turning this 15 into a 0. So I got 1, -2, 3, 5. I'll have 0, 3, -5, -6, 0, and then 0. And then we have 5 times -5, which is -25. Add it to 25, which is 0. And then we will have 5 times -6, which is -30. -30 plus 77 is 47. Okay, so we have this row right here, which basically says that 0x plus 0y plus 0z needs to equal to 47. You don't need to write this, but I'm just saying it. So this is an inconsistent system. Which means that there's no solution, which means no intersection. Okay. Then verify that point P, however, does lie in both the first and second plane. So verification is easy. You have x, y, z, just plug it into each x, y, and z. So for plane 1, we have 2 times 1 minus negative 2 plus 0. And then does this equal 4? Yes, it does. For the second plane, it is 1 minus 2 times y plus 3 times z. And then does this equal 5? And then obviously it will. So verified. Okay. Then we need to find the vector equation of L, which is the line of intersection between the first two planes. So we do know that there is a point that's on both the first two planes, which means that those two planes intersect. And they're going to intersect in a line, apparently. Okay, so this is easy to do. Let me give you a little quick visual. I did explain this in the November paper, but if you have two planes, here's your intersection. Okay, the normal vector of the red plane is towards my right, let's say. The normal vector of my second blue plane is going up. And then notice that the line of intersection, it needs to have a direction vector that is perpendicular to the two normals. So what we need to do is find the normals of each plane, which is easy. Those are the coefficients of the variables in the equation. And then we need to find a vector that is perpendicular to both of them. So let me just do that. The normal vector of the first plane is 2, -1, and 1. The second vector is going to be 1, -2, and 3. And then to get a vector perpendicular to both of them, we take the cross product or the vector product. Ugh, and I hate doing these because I don't know, I just don't like the formula. Hold on, let me just do it my way, which is the way that I learned in university. And unfortunately, it's not something that I really want to teach you guys because it does require you to know a little bit extra work. It'd be faster if you just followed the formula. But for me, I personally think this is faster. So this vector is going to be, what's -3 plus 2? -1. And then what is 6 minus 5? 6 minus 1 is 5, so this is -5. And then lastly, -4 plus 1, which I think is -3. Okay. I don't even know if this is right, but whatever. I know what to do. This is the process. This might not be the actual right cross product, and I'm too lazy to do the ugly formula in your formula booklet. But you guys can do that. Okay, So here's the direction vector of my line. So the equation of my line is going to be a position vector of a coordinate on the line, which they already told you is point P, 1, -2, and 0. And then we're going to add some scalar multiple of our direction vector. Easy peasy. Okay, and then lastly, find the distance between the line and the third plane. Okay, so if you think about it, remember that the three planes do not intersect all at once. So there's not really that many situations where two planes can intersect and then the third one doesn't intersect with them at the same place. You could have something like this, I guess. Here, so here's plane 1, here's plane 2, and then here's plane 3. You could have also, I think, plane 1, and then let's say this is plane 2, and then plane 3 will intersect both of them but in different locations. And then in any situation, it doesn't even matter, but essentially this line is not going to obviously intersect the third plane, and this line is going to be perpendicular to the normal of the third plane. So here. Hold on, let me skip this song. I don't know if you guys can hear it, but I do not like this song. Oh, that's loud. Hold on, I'm gonna turn that down a little. Okay, what was I saying? Yeah. So your third plane, for example, could be parallel to the one of the planes like this. So my third plane, the light blue one, is parallel to the darker blue plane, and then that means that the green vector, or the green line, is going to be perpendicular to the normal of the blue vector, because the normal of the blue plane, because the blue plane and the dark blue plane are parallel, so they have the same normal vector. The other situation, which was what I drew, and then this one's kind of hard to do in 3D, but basically it intersects them both. Yeah, this is hard to draw. But either way, this green line is going to be a fixed, this is the main point. The green line is always going to be a fixed distance away from the third plane, no matter how you orient the plane, because you know that it doesn't intersect the other two planes at the same place. That's the main point I'm trying to make. So anyways, what that means is, for example, here's your line R. And then your third plane let's just say is kind of hovering below it. It's hard to draw 3D in 2D space. But if we want to find the distance between them, then we can just take any point that we want to, really. From this line, and then we calculate first off so we can use our point P, which is this one right here, 1, -2, 0, and then we can connect it to, I don't know, this point that is directly, I guess in this case below it, on the third plane. I don't know what to call this. I'll call it a P prime, because that looks legit. Okay. And then the direction vector of your line is the normal vector to the third plane. Okay, so step 1. I need to find P prime, because when I have the coordinates of the 2 points, I can calculate the length between them. To do that, I need the equation of the vector equation of this line, the distance line. So I'll call that S, I guess. And it's we can reuse the same point, but the direction vector, well, I guess I'll use a different scalar, so I'll call it mu. But the direction vector of this line is, like I said, the normal to the third plane. So it's -9, 3, and -2. Okay, and then what I can do is, this is basically an expression for any point on this line, which includes point P. And at the same time, I also want point P to satisfy the third equation, or the third plane's equation. So what I can do is I can parametrize my coordinates. So P prime I can write as 1 plus, or parametrize, I don't know if that's how you spell it. So my x is going to be 1 minus 9 times mu. My y is going to be -2 plus 3 mu. And my z is going to be -2 mu. Okay, so according to the vector equation of this line, point P prime must be in this format. And then at the same time, these x, y, and z's need to belong in the plane, so I can plug those in for x, y, and z in the plane equation. Okay, so plugging them in for x, y, and z in the plane equation. And then this will help me find mu, by the way. And then I can go back and then plug it into these coordinates, or these equations, to get the actual point P. Okay, and then this is all equal to 32. Oh boy, okay, here we go. -9 plus 81 mu, minus 6 plus 9 mu, plus 4 mu equals 32. Okay, 32 plus 6 is 38. 38 plus 9 is 47. So just, sorry, adding 9 and 6 to the other side. Okay, and then I collect my mu's together. 81 plus 9 is 90. 90 plus 4 is 94. Which means that mu is going to be, I think this is 1/2, right? 47 divided by 94 is 1/2. Nice. So that means that p prime is going to be the position vector 1 plus half of 9, or sorry, 1 minus half of 9. Oh boy, okay, so this is -7/2. And then we have 2 plus -2 plus 3/2. I think that's -1/2. These are, I'm getting a little worried. These look kind of ugly. And then this is -1. Okay, we can also write it as coordinates too. And then finally we can find the distance between P and P prime. Okay. So P was what, 2, 0, -1 or something? No, 1, -2, and 0. Okay, so then your distance is going to be 1 plus 7/2 squared plus -2 plus 1/2 squared plus 1 squared. Okay. Nine over 2 squared plus -3/2 squared plus 1. 81/4 plus 9/4 plus 4/4. Man, this sucks. And then what is this? 94/4? I don't want to reduce this or simplify it anymore. I'm gonna just say that that's the distance. And maybe the numbers are wrong because I did some small math error somewhere, but that's the process that I would do to get that distance. Okay. And then I think there's only one more question. Okay, boy, Maclaurin series. Those aren't that bad. Find the Maclaurin series for e to the x times sine of x up to including the x cubed term. So each one of these individually, e to the power of x and sine x, have their own Maclaurin series. So what we can do is we can just expand them out. So e to the power of x is 1, and then I need my formula booklet because who the heck remembers what the Maclaurin series are? Okay, 1 plus x over 2 and so on. Sine x Maclaurin series x minus x over 3 factorial plus x to the power of 5 over 5 factorial. I don't even need to include that one because we only want to go up to the x cubed term. So think about all the terms that when you multiply them together make x cubed, or up to x cubed. So we have 1 times x, which is x. we have 1 times negative x cubed over 3 factorial. So that also counts. If we were to keep going, we would get higher powers of x. So now we multiply x with x. That will make x squared. And then I think that's it, because if I take x and multiply by the next term, I'll get x to the power 4 or more. And then lastly, x squared over 2 times x will make x cubed over 2. And then I don't know if they want you to include the dot dot dot, but I'll just include it anyways. Okay, and then we can collect some like terms. 3 factorial is 6. And then if we want to write this as with the denominator 6, then that's 3 in the numerator. So we have basically 3 6 minus 1 6, which is 2 6, which reduces to 2 6 reduces to 1/3. Okay, so there you go. Hence, find an approximate value of this integral. So I think it was e to the x squared though. Yeah. Okay, and then this is the beauty of the Maclaurin series. So this is approximately equal to the Maclaurin series that we just figured out, but we replace x with x squared, because this was a Maclaurin series for just e to the power of x sine x. So this is x squared plus x to the power of 4 plus x to the power of 6 over 3 dx. So this is going to be 1/3 of x cubed plus 1/5 of x to the power of 5 plus 1 over 21 x to the power of 7, evaluated at 1 and 0. If you evaluate it at 0, then it all goes away, so this is just 1/3 plus 1/5 plus 21st is whatever, 1 over 21. Oh my god, okay. And then the lowest common factor of this is I think like 105. Whatever, okay. I'm gonna multiply this by 5. I'm gonna multiply this by 21. And I'm gonna multiply this by 35. Because this is basically 3 times 7. So my lowest common denominator is 3 times 7 times 5. Okay, so I'll have 35 plus 21 plus 5 over 105. So 56 plus 5, I think is 41. So there is your integral. And then we have g. Okay, show that g satisfies this equation. So the double derivative. Okay, I'm gonna copy this. Okay, So g is e cosine x. So let's write down what g prime is. We're going to use product rule, so it's e x cosine x, and then minus e x sine x. Okay. And then we should take the second derivative, I guess. So we already took the derivative of the first term. So this is just going to be this again. And then we will need to take the derivative of the second term, minus bracket. So ex sine x plus ex cosine x. Okay. So g double prime is 2ex cosine x. Or sorry, cosine. Why am I writing pi? These should be x's. Okay, minus 2ex cosine x. And then I can factor out a 2. I'll get ex cosine x minus ex. Oh, this should be sine. And then this should be sine. And then I'm supposed to show this, right? Okay. Wait, what's g prime minus g? This is g prime. If I minus g, then I minus this. So I just have that part. Oh, something. Okay. Oops, I messed up. Sorry. So these cancel out. You will get negative 2ex sine x. And then this is equal to 2 times negative e sine x. And then this is equal to 2. And then I'm basically trying to show this, right? And that's easily done because I already know what g prime is from earlier, right here. I don't know, maybe there's a more elegant, better way to do this, but yeah. So obviously negative e to the sine x is the same as this. And then I know that this is g prime of x, and then this is minus g of x. Whatever. Okay. Next up, hence deduce that the fourth derivative is going to be this. Okay, sure. We'll try it out. Okay. So using this from the earlier part, I'm going to take the third derivative. So the third derivative is then basically going to be 2 times the second derivative minus the first derivative. And then I'm going to find the fourth derivative. This is basically 2 times the third derivative minus the second derivative. And then I'm going to make a substitution for the third derivative because my question only has the fourth derivative. Oh, actually, no, it doesn't. It's right there. Okay, then we're done. Easy. Then, what do we do? Using the result from part C, find the Maclaurin series for g of x up to including the fourth term. Why? Why do I have to use this? Why can't I just use the Maclaurin series in the formula booklet? Oh well, okay. I guess that's why they asked you to find the first, second, third, and fourth derivatives. So in general, Maclaurin series is this formula and then what did they want? Up to including the fourth x to the power 4. Second derivative at 0 over 2 x squared plus third derivative at 0 over 3 x cubed, and so on. Okay, so oh right, this is for g. So g of x. What is g of 0? So g of 0 is 1. Okay, what is g prime at 0? So this is 1, this is 0. So g prime at 0 is also 1. So then that's just 1 times x. And then f prime at 0 is 2 times g prime. Oh right, okay, let's write this down. Okay, hold on. Let me change these to g's just so that I can keep track of things better. G, 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 G. And then, like I said, I know that this is 1, and then this is also 1. Right? This is 1, this is 1, that's 1, but that's 0, so it's just 1. Okay, so g double prime of 0 is going to be 2 times g prime at 0 minus g prime at 0. Both of those things are 1, so 1, 1. So g double prime is going to be 0. So we don't have an x squared term. And then triple prime at 0 is going to be the double prime at 0, which we know is 0. And then the first derivative at 0, which we know is 1. So this is 2 times negative 1. So this one is negative 2. Okay, so this is going to be basically minus 1 over 3 x to the power 3. 3 factorial has a 2 in it, which will cancel with that 2. And then lastly, to the power of 4. So this is negative 2. G to the third prime is negative 2. G to the second prime is 0. So g to the fourth prime is negative 4. 2 times negative 2. Hopefully you guys are following along. So g4 of 0 over 4 factorial times x to the power 4. Okay, and then we just found out that this is negative 4. So we will have negative 1 over 6 x to the power 4. Because this 4 is going to cancel out with the 4 in the factorial, which leaves 3 times 2 times 1, which is 6. Okay, so I think this is it. And then I think there's only one more question left, right? Which is finding a limit. And this will be easy. Copy. Paste. And how am I doing for time? A little over an hour. Okay. So what we're going to do is we are going to find this limit by first replacing the ex cosine x with our Maclaurin series that we found out. So it's 1 plus x minus 1 over 3 x to the power 3 minus 1 over 6 x to the power 4, and then minus 1 minus x divided by x to the power 3. Okay, so this cancels with that, that cancels with that, and then this x cubed is going to divide into the terms of the Maclaurin series. Oh, I guess I should do plus higher powers of x. Okay, so then all of this is going to simplify into negative 1/3 plus powers of x, basically. So when I evaluate the limit, anything that has a power of x is going to become 0. So my limit is 1/3. Okay, and I think we're done. So not bad. Honestly, I think that this was a pretty straightforward HL paper. However, the SL questions were not quite as straightforward. Like, for example, this plane question, there was something very similar in November's paper earlier. This one's pretty straightforward. This one's very easy. This one is more or less pretty straightforward. This one's kind of tricky. But yeah, honestly, not that bad of an HL paper. This one's kind of weird, but this question, but overall it's not that bad. Okay, I think that's it for now. We'll wait for paper 2 to show up, and then on Thursday next week, paper 3 for the HLs. Thanks for watching. Hope you guys did well. Yeah, and again, probably did something wrong in here, but whatever. The math is right, at least the process. Okay, goodbye.